Okay, hello everyone. We are up to 5-6. We're doing part 1, the introduction to logarithms. It's a pretty significant thing in math and something that is well worth investing the time to understand at the beginning. The motivation for logarithms comes from the fact that we need to be able to solve problems. Anytime we have a mathematical operation, we should be able to look at it as two sides of a coin. We should be able to undo it. So here, if we have 2 plus x being equal to 10, to get x by itself, we should be able to undo this operation, and the opposite of adding 2 is subtracting 2. So if I just subtract 2 from both sides, I get my solution, 8 is equal to x. All right? So I can do that for each of these. I can divide both sides by 2, and I guess I'll write it over here. I will get 5 is equal to x. Here, when we have 10 being equal to x squared, I can square root both sides, and I will get x is approximately equal to about like 3.1 or 3.2. So we can not necessarily get an exact answer, but we can represent it with a decimal approximation that's very close, or we could write exactly equal to square root of 10. However, when we get to something like this, we don't have a handy way of just undoing it. Sometimes beginners will want to take the square root, or they'll want to divide by 2, but as you can see, that is not the way to go. It will not give you the right answer. We can guesstimate it by saying, well, I know that 2 to the 3rd power is 8, and 2 to the 4th power is 16, so it's somewhere between 3 and 4. Maybe it's like 3.1, and you could go to your calculator and sort of guess and check. But what really, the better way to understand it is to come up with an actual operation, a mathematical operation that will undo it. And that's what a logarithm is. A logarithm is defined as being the inverse operation for an exponential. All right? So the way we do it is we'll say, well, okay, the invention of a logarithm is really to get this by itself. All right? That's the purpose. So to get x by itself, I am going to take the log with this as the base of this number. So this is my base number, and I'll do log base 2 then of 10. We say it's not multiplying by 10. We'll say log base 2 of 10. That is equal to x. So this is the key relationship that you need to understand between an exponential and a logarithmic form of an equation. A lot of your homework will be going back and forth between these two. Okay, so as a simple example then, one of your homework problems might be, what is the log base 5 of 625 equal to? All right? Well, to solve that, we need to get it out of logarithmic form and into exponential form, so we can do it by inspection, by just looking at it. So I'll say let that be equal to some mystery number x. The way we translate it from log form to exponential form, I think most easily, is just to simply cover up the log and draw a little arrow over and keep that base number there. That is the base upon which our exponent is built. All right? I hope that's not chopped off. I'll maybe rewrite that right here. When you cover up the log and you get rid of that, you get then 625 is equal to 5 raised to the x power. Okay? This is where that handy sheet of numbers comes in. 5 squared is 25. 5 to the 3rd is 125. It's 5 to the 4th equals 625. So 5 to the 4th is going to be equal to 5 to the x. So clearly x is equal to 4. Or this whole value then will be equal to 4. And I've solved it. All right? So there are two conventions that you need to understand when dealing with logarithms, and that is that we have two bases that we come back to over and over again. The first is base 10, because our number system is base 10. So we would write log of 10,000 as being equal to 4. And the reason we get 4 here is that if we realize that that's an unwritten 10 there, a log with no number is understood to be base 10. So there I'm writing it there, and using my arrow method, I just bring that over, and 10 to the 4th power is going to be a 1 with 4 zeros. So it's no more difficult than just counting zeros in a problem. All right? So if you had a question that was, write the following in logarithmic form, okay, you would write this in logarithmic form as the log of 100,000 is equal to 5. These are equivalent statements. Okay? The other logarithmic base that we run into a lot is the natural logarithmic base, and we denote that by not writing log base e, but we write log with an n there. Oops, sorry. ln, natural log. All right? So if I said the ln of 1, what is that equal to? Well, you'd say, okay, well, the ln of 1, that's equal to some mystery number. I'll rewrite it. Call that x. Well, that's really base e. So if I bring that e over as my base number, e to the x is equal to 1 if and only if x is what value? 0. Very good. All right, so that's what you need to know to get started. You can go to the second video in which I do a couple of examples, and you can definitely take a crack at the homework. Good luck.